Hi everybody, this is our study guide for practice test 3. This one had 21 questions on there, so I guess the number of questions just vary from test to test. Alright, we're going to get started with question number 2. Mark all of the numbers below that are solutions to the equation cos of theta equals secant of theta. So if you look at secant of theta, that is the same thing as 1 over cos of theta. So if I look at pi over 6 over here, that would be 30 degrees. So this one has to be the 1 because the 3's can't be diagonal from each other. So this would be the 2 and this would be the square root of 3. So cos of that would be square root 3 over 2. And the secant is just flipping that around, so that would be 2 over the square root of 3. And those would not be the same, even if you reduce this and make it more proper, and that's 2 square root 3 over 3. These are still not the same thing. So what we're looking at is that the top and the bottoms would be the same. So that will not happen on a pi over 6. Or anything of the version of a pi over 6. So as I look at the next page, these are the other answers. So anything that has a pi over 6 is not going to work because all of the other ones would just change it to being positives or negatives. So none of the pi over 6's will work for this problem. If I look at pi over 3, that would be a 60-degree angle. So across from the 60s would be the square root 3, the 2, and the 1. So if I looked at that, the cos would be 1/2, versus when I flip that, I get 2 over 1. So that would never work. So all of the pi's over 3 would be a similar variant. None of those would work for this. All right, looking at the pi's over 2, so it would be right here. We would have to force a fake triangle here. So remember, the hypotenuse on the fake triangle would always be a 1. Since this is going up and down, then this goes up and down. This would be your 1, and this would be your 0. So if I look at that one, the cos would be 0 over 1 versus the secant would be 1 over 0. So this one would be 0, and that one would be undefined. So all of the pi's over 2 would not work. This one would just be the negative. It'd be the same thing. So if I look at regular pi, that would be over here. So I would draw my triangle out over here. Remember, the hypotenuse is always 1. Since this is the real side, that would be a negative 1, and that would be 0. So we would be looking at negative 1 over 1, which is negative 1. And the other way would be 1 over negative 1, which is negative 1. So anything that has a pi, whether it's pi or 2 pi, it's just the other one just makes them be positive ones instead of negatives, would work. So those are your 2 answer choices. Of course, you could always type these into the calculator and you could check your decimals. Might take a little bit longer, but that would work also. If you are going to use the calculator, make sure your calculator would be in radians. If your calculator is in degrees, it wouldn't work right. So just remember, if you want to do that, make sure that it is in radians. And again, I will star all of the ones on the practice test that I saw on my version of the test that I opened up. And this was definitely similar to one on there. Okay, question 3. I also saw something similar to that. The picture below was shown as an explanation of how the sum and difference formulas arise for the sine and cosine functions. What equation comes from the fact that the red line on the left is the same as the red line on the right? Okay, so it's hard to see because these are not printed in color, but your red line would be right here, and your other red line is right here. So basically what we are looking at is the distance formula. Since we want to calculate the distance between 2 points and we want to show that they are the same. So the distance formula is x1 minus x2 squared plus y1 minus y2 squared. Of course, you can put x2 minus x1. It doesn't really matter, okay? All right, so we will say that this point is x1, y1, x2, y2, x1, y1, and then x2, y2. Okay, so when I plug these in, so my x1 would be cos of alpha minus cos of beta, and that whole thing would be squared, plus y1 would be sine of alpha minus, and then this one here would be right here, sine of beta, and that whole thing would be squared, equals, and we'll do the distance formula over here, so x1 would be cos of alpha minus beta minus x2 would be 1, and that thing would be squared, plus over here I have sine alpha minus beta minus 0 squared. Okay, and then you're just going to look and see which ones are your answer choices, which matches, so that would be the bottom one down there. Okay, question number 4. This one I saw on the test. It looks a little confusing, but it's really not that bad. So the curved plot in black is y equals 7 sine x plus x, and the horizontal line is the y equals 1. Study the graph and figure out how many solutions you have. So basically you are counting how many times the graph crosses. So right here I've got 1 and 2, so I have 2 negative. And over here I've got 1 time across, 2 time across, 3 time. So 3 positive. So once you know all you're doing is counting how many times the thing crosses the line and counting the positives and the negatives, this one looks like it's on the line, but it's really on the positive if you were zooming in. So this answer would be 2 negative and 3 positive. And that's the one you would pick. Okay, question number 5. Match the identity to its type. I did not see this one on the test. If it was on the test, it would actually be very helpful because you would have your formulas there and you wouldn't have to memorize them. So number 1, 1 plus tan squared theta equals secant squared theta. That is letter E. Pythagorean identity, because it's like an a squared plus b squared equals c squared. Cotan theta equals 1 over tan theta. That is B, the reciprocal identity. Cos of negative theta is equal to negative cos of theta. That is F, not an identity at all. Cos of pi over 2 minus theta equals sine of theta. That is A, complementary angle theorem. Sine of 2 theta equals 2 sine theta cos theta. That is D, your double angle formula. Because of the 2, it's double. Tan of negative theta equals negative tan of theta. That is G, that's your even odd identity. And cos of alpha divided by 2 equals plus or minus the square root of 1 plus cos alpha divided by 2. Well, alpha over 2, that has to be the half angle formula. So that's C. Okay, I did not see that on the test, so I would probably make sure that you memorize the identities. since it may not be on there for you to know what they are. Okay, question number 6. Again, I didn't see that one on there. I would definitely have these memorized. If this question was on there, it would be very helpful because then you would at least have a gander of which identity you are using. Sine of alpha plus b, or alpha plus beta, or a plus b, that is letter D. So just memorize these. Sine a minus b, that is A. Cos of a plus b, that is C. And cos of a minus b, that is letter B. So make sure that you have these memorized. Of course, if this was on your test, these would probably be in different orders. Okay, question number 7. I did see one similar to that on there. Match the trig function value. So at this point, you should pretty much have these memorized, but if you don't, we will draw the triangles again. So pi over 6, that is 30 degrees. And I memorize it because I think 6 and 60, the 6's don't go together and the 3's never go together. So this is 30 degrees. So remember, the 3's never go diagonal, so that has to be 1. Square root 3, hypotenuse is always 2. So sine would be 1 over 2, so that would be D 1/2. Pi over 4, you should have this one memorized. So remember, the hypotenuse is always 2. Pi over 4 is 45 degrees, so these are square root 2's. So it's square root 2 over 2, so that should be B. Sine of pi over 3, that would be 60 degrees. So remember, diagonal is always 2. The 60 square root 3 has to be diagonal. The 1 is always across from the 30. So that would be square root 3 over 2, which would be C. Sine of pi. So I would come over here. Here would be your pi. Here's our fake triangle. Remember, the hypotenuse is always 1. Since this is the real side down here, this would be a -1, and then the fake side would be a 0. So that would be, sine would be 0 over 1. So that would be 0. And pi over 2. Draw that over here. So that would be up here. We'll make our fake triangle over here. So remember, the hypotenuse is always 1. Since this is the real side going up and down, this would be a 1, and that would be your 0. So 1 over 1 would be 1. So this would be E. Okay, question 8. I did not see this one on the test either. That doesn't mean it won't be on there. It just wasn't on the version I saw. Okay, mark all of the following that is true. Cotangent and tangent always have the same sign where they are both defined. That would be true because they are kind of like reciprocals of each other. So that would be true. In quadrants 1 and 2, the tangent and cosine have the same sign. All right, so let's look at this. Always skip trig class. So this is quadrant 1, quadrant 2, 3, and 4. So in quadrants 1 and 2, quadrant 1, they definitely have the same sign because all of them are positive. In quadrant 2, sine is positive, which means tan and cosine would be negative. So this is a true statement. Secant and tangent never have the same sign. Well, look at quadrant 1. They have the same sign in quadrant 1, so that would be false. You would not checkbox that. So quadrant 1 makes that false. The sine and cosecant always have the same sign where they are both defined. So they are kind of reciprocals of each other, so that would be true. In quadrant 2, the secant is negative and the tangent is positive. So I look here, tangent is negative, so that would be false just based off of that. In quadrant 4, the cotangent is positive and the cosecant is negative. So if I look over here, cotangent would have to be negative because tangent is negative. So that would be a false. Okay, in quadrant 2, the sine is positive and the cosine is negative. So if I look here, sine is positive, cosine is negative, that is true. Okay, and I think the one that cut off, I put it on the next page over here. Okay. All right, quadrants 1 and 2, sine and cosine have the same sign. Well, in quadrant 1 they do, but in quadrant 2, cosine would be negative, so that would be false because cosine would be negative. In quadrant 4, the sine is negative and the secant is positive. So quadrant 4, sine is negative and secant is positive. Well, secant's the opposite of cos, and cos is positive, so that is true. Sine and cosine never have the same sign. Well, look at quadrant 1, that's false. Okay, question number 9. Okay, so we can go ahead and star 9, 10, 11, and 12. Just go ahead and do that so we don't forget. I've seen all of these similar on the test. Of course, sometimes they will be identical, which you really have to watch for, and sometimes they will just change little things. So just really make sure you read very well on your test. All right, the conventional domain for cos of x is restricted to 0 to pi in order to define cos that y equals the cos inverse of x as a function. Which of the following intervals could also be the restricted domain of cos of x in order for it to be invertible, making y equals cos inverse of x its inverse function? Select all that apply. Okay, so if we were drawing this, cos would start out at 1, and it would end at 2 pi. So this would be 3 pi over 2. Right here would be pi over 2. All right, and we'll continue that on over here. So over here would be negative 2 pi, negative 3 pi over 2, negative pi over 2. Okay, so if I'm looking at this, I need to pass the horizontal line test. Okay, so if I'm looking at this, if I look from negative 1 to 1, so that would be from over here to over here, it would give me a U shape. So that would be no. Okay. All right. Look at negative pi over 2 to positive pi over 2. That would give me a U shape. So that would be no. If I look at negative 3 pi over 2 to positive 3 pi over 2 to positive 5 pi over 2. So 5 pi over 2 would be over here. This would continue on, of course, so that would give me a U shape. So that would be no. All right, negative 2 pi to pi. So if I look from here to here, you see where it just is a slant. So if I brought my pin down, I would only touch it one time. So that would look kind of like that. So this would be a yes. negative pi to 0, so from here to here, that would be kind of the same thing. It would just look backwards like that, so that would be a yes. That would pass the horizontal line test. And from pi to 2 pi, so pi to 2 pi, that would look like that, and that would be a yes. Question number 10. The inverse sine function is given by the equation y equals sine inverse of x. This equation is equivalent to which one of the following equations? All right, so what you want to do is you want to switch x and y. So instead of saying y equals sine inverse of x, we're really going to have x equals the sine of y. And that's the one you're going to pick. So that is this one down here. So that's just knowing a definition of what does inverse mean. You're switching x and y. Okay, question number 11. True or false? The sine inverse of sine of 3 pi over 4 equals 3 pi over 4. All right, so to solve this equation, there's a couple different ways you could go about doing this. It just depends on how you're thinking at the time. If you looked at your index card, you should have these memorized for test 3. So if I look, sine inverse sine of x equals x between negative pi over 2 and positive pi over 2. If I look at 3 pi over 4, that is not in between that interval. So this one would be false. Okay? The other thing that you could do if you didn't have that memorized, I would type it into the calculator. Make sure that you are in radians since pi, you have a pi there. So sine inverse sine, and this is 3 pi over 4. I'm going to use the ABC button for my fraction. And that, and I get a syntax error. So that is because it's not in that domain of negative pi over 2 to positive pi over 2. So that's why it's false and it won't work. So you could use your calculator, or you could just have it memorized, and you should have that memorized. Okay, question 12. Simplify. Tan sine inverse of 3 over 7 approximate to 2 decimals. This is definitely easier if you just use your calculator. So tan sine inverse 3 divided by 7, and I get 0.47. Make sure you read because he likes to change these up a lot. So 0.47. Make sure that you use your rounding rules. So round up, 5 and up, round up. Because this last number was a 4, the 7 will stay. You do need to use the rounding rules. Make sure that you are in radians in the calculator. Okay. All right, next page. So 13, 14, 15, and 16. Go ahead and star all of those ones. All of those ones, I saw similar ones on the test. Question 13, simplify cos of x minus y minus cos of y plus x. All right, so this is making sure that you know your cos alpha plus beta and your sine alpha plus beta, the positives and the minus rules. So if I look at cos alpha minus beta, so they're using x and y instead. We're going to use that this is cos x cos y plus sine x sine y minus, and because this is a quantity, you need to have parentheses or a bracket right there. Quantity And we're going to use the plus one. So cos x cos y minus sine x sine y. Okay, now this negative on the outside, we need to distribute that here and here. So that's going to go positive, that will go negative, and that will go positive. So if I look, this and this, they're going to cancel out. So those are gone, and these match, and since there's two of them, that will be 2 sine x sine y. Question 14. Simplify cos 4x minus sine 4x divided by cos of 2x. Okay, now the little 4, since those are exponents, we can rewrite that. So this is going to be cos squared x, and the square goes there. So we're just rewriting the 4 power as 2 to the 2. Minus sine squared x squared divided by, now cos of 2x, we're going to need to change that since these are squares. If you look on your formula sheet, I'll figure out where mine's at. Here we go. All right, you got 3 options. So I'm going to choose the first one right there, cos squared minus sine squared, because I've got a cos squared and a sine squared, and maybe I can cancel some stuff out. So we're going to use cos squared theta. Well, I guess x or theta, it doesn't matter. I guess I should stick with x. Minus sine squared x. All right, so all of this stuff on the top, you're going to need to factor. All right, so we're going to recall some stuff from the college algebra class that we had done previously to this class. So a squared, put a little line here, that had nothing to do with question 13, minus b squared is equal to a plus b, a minus b. All right, now let's do an example that you're more used to seeing, that you would have seen in the college algebra. So x squared minus 64. So that's saying you basically square root both of these. So I have x plus, and the square root of 64 is 8. So x plus 8, x minus 8. Okay, so that should recall some memories there. So we're going to do that kind of factoring with this down here. So this is going to turn into cos squared x minus sine squared x. Okay, so that's our first set of parentheses. Okay, and those are coming because the square root of that is that, and the square root of sine x squared is sine x squared. So that's your first set of parentheses. I just flipped these around. Okay, the other one is going to be the exact same thing, but instead of a minus in between, it'll be a plus in between. So the square root of that would be cos squared x plus sine squared x. So this concept came from up here. Just think that this was your x, and your sine squared was kind of like your 64. So you square root both of that, and they give you just themselves. Okay, divided by cos squared x minus sine squared x. All right, now this is going to make you recall right here. So recall cos squared x plus sine squared x equals 1. So this whole thing is just equal to 1, so it's basically not there. So I'm left with cos squared x minus sine squared x divided by cos squared x minus sine squared x. So this guy turned into a 1, and I was left with these two, and this divided by this is 1. So our answer is 1. Since these were identical, it's the same thing as saying 4 divided by 4 equals 1. It's that same concept. Since everything matched up, we're just using that property. Question 15. When using the half-angle formula to compute cos of 17 pi divided by 12, will you use the positive root or the negative root? And they want you to type in the entire word, positive or negative. Don't abbreviate or anything. Don't put the parentheses around it or the quotation marks around it. Just put in the word, okay? All right, so here we go. So we have our always skip trig class. So you're looking at this here, and you need to figure out what quadrant that is in. If you can figure out what quadrant that's in, then that will tell you if it needs to be positive or negative. So we're going to go 17 pi over 12 times, now remember we're using 180 and pi, you want the pi's to be diagonal. So pi and 180. If I calculate that out, that's 255 degrees. Okay, so I know that this is 180 right here. This is 270. So I know that the 255 has to be somewhere right here, where tan is positive. So we're looking at cos. So since cos is negative in quadrant 3, I'm going to enter the word negative. And you would type that out exactly the way it is. If you do anything fancy, you're going to get points taken off. Okay, question 16. Find the exact value of the expression sine tan inverse of 2. And I would use my calculator to do this. I think that would be the easiest way of doing it. So I would type in the calculator sine second tan inverse 2. All right, so that gives me a decimal of 0.89. And then what I would do is I would go through all of your answer choices and figure out which one is the same decimal. So we have 2 square root 5. Get a number and we'll divide that by 5, and that's your answer right there. All right, now if you wanted to do this without the calculator, what you would have to do is, and you can see the calculator went super quick. Without it, you would say alpha equals the tan inverse of 2. So the tan of alpha equals 2. That's kind of like a rule. So then we would come over here. So tan is 2, so there's your alpha right there. So 2 over 1. Then I would have to do Pythagorean Theorem to find the hypotenuse. So 1 squared plus 2 squared equals c squared. So we're looking at a 1 plus a 4, which is 5, equals c squared. So I know that this has to be the square root of 5. Okay, so then we would do the sine of alpha. So opposite over hypotenuse. So 2 over the square root of 5. You need to simplify that. So times by the square root of 5, top and bottom. So I get 2 square root 5 over 5. And that would be the long way of doing question 16. So it really just depends on which method you want to use when you are solving this. All right, question 17. Use the calculator to find the value of the secant inverse 3 in radians measured to 2 decimal places. All right, so the secant inverse of x is equal to the cos inverse of 1 over x, since those are kind of like reciprocals with each other. So I am looking at the cos inverse of 1/3. And I would type that in. So second cos 1 divided by 3. And that gives me 1.23. And make sure that says radians. So you better make sure your calculator's in radians when you type it in. 1.23. I did not see this one on the test. Okay, question number 18. Mark all the values below that are solutions to sine of theta equals 1/2. All right, the easiest way of doing this is to type this in the calculator. Make sure your calculator is in radians. All right, so you're going to use your answers and plug them into theta. So sine pi divided by 6, and that gives me 0.5. So that's an answer. Just type this over, and then I get 3. Nope. Type over 2 pi. I like using the ABC button when I'm doing fractions. Okay, that doesn't work, so that's a no. 5 pi over 6. Syntax error. 7 pi over 6. Syntax error. Thinking this might not actually work for all of your answers. I think if you did it this way, you might only get half of your answers right. Oh, I think I need to use the actual divide. Oh, yep. All right, you can't use the ABC button. It does not work. All right, let's try this again. 2 pi divided by 3. 2 pi divided by 3. Don't use the ABC button with pi. That's the lesson learned. Okay, 5 pi over 6. That works. So as long as you don't use the ABC button, you're okay. So we'll make a note on that. Don't use the ABC button. And I did see this one on the test, okay? Don't use the ABC button. All right, just go through all of your answers. Make sure you take your time on the real test so you're not missing anything. 4 pi over 3. 5 pi over 3. Nope. And 11 pi divided by 6. No. So it's just those two answers. That is definitely the fastest way of doing it. If you want to do it the longer way, I can show you how to do that here. So what we would say is, here we have to draw it out. And you can see how much more tedious this way will be compared to just plugging it into the calculator. So I know that this has to be a 1, that has to be the 2, so diagonal from the 1 is always the 30 degrees right there. This would be your square root of 3. So because this is 30 degrees, I know that this is a pi over a 6. So then this is where you have your theta equals pi over 6 plus 2 pi k. All right. So then you go through and you have to pick k equals -1, k equals 0, k equals 1, and k equals 2. This is definitely the longer way of doing it. So I plug in -1 here and I got pi over 6 plus -2 pi, and that gives me -11 pi over 6. Plug in 0 and that gives me pi over 6. Plug in 1. I have pi over 6 plus 2 pi, and that gives me 13 pi over 6. Plug in 2 and I get pi over 6 plus 4 pi. So that gives me 25 pi over 6. Okay. And then that angle also reflects over here, because if you look at your always skip trig class, you know that sine is positive in quadrant 2, so this is my 1/2, and then here would be negative square root of 3. So this would be 5 pi over 6. So then I have to perform this same thing with 5 pi over 6. Plus your 2 pi k. And again, you would go through k equals -1, 0, 1, and 2. When you plug that in, you get negative 7 pi over 6, 5 pi over 6, 17 pi over 6, and 29 pi over 6. So you can see the only answers that worked was when k was 0 with pi over 6 and 5 pi over 6. That is definitely the really, really long way of doing this problem here. Okay, I would probably stick with the calculator, make sure it's not using the ABC button. Okay, question 19 was on there. In the picture below, angle CAD is theta. How can you interpret the length of the green line? Okay, so we're looking at this. This was teal. This was purple. And this teal line technically goes all the way across to over here, okay? This was yellow. And this here was the green line, going from here to here, all right? So if you look from here to here and here to here, you can see that this line and this line, the line doubled. Okay, and because it's going up and down, you're going to use y, the sign, because it's on the y-axis. If they were asking about the line going this way, side to side like that, cos would be what you would use. Cos would be the x-axis direction. So if you look from here to here, the line doubled, so you're going to use sine of 2 theta. All right, then we're going to turn this over and use just the back as like a scrap paper so that we can get some extra problems in that you will be also looking for on the test. So consider the inverse cosine function. Okay, is it true that the cos inverse of cos of x equals x? Explain why it is always true. Or give a counterexample. Okay, and I would probably pause the video and copy this down on a piece of notebook paper or on the back page of your study guide. So if we are looking at this, we just need to give one example or a counter example of why this would or would not be true. So if I look at this, you really, really need to memorize these for your test. It would be most helpful if you had it memorized. So if I'm looking at cos inverse of cos of x equals x, that is true where we are between 0 and pi. Okay, and it could equal 0 and it can equal pi, but it has to be between there. So this is going to be false because it is only true between 0 and pi. And then you'll need to give a counterexample since this one was not always true. So when you have 4 pi over 3, and then this is when your calculator comes in handy, you can type this in. So we have cos inverse 4 pi divided by, oh wait, hold on, I didn't even type that in right. Okay, cos inverse cos of 4 pi divided by 3. Okay, so that says that, so when you have that, the cos inverse of cos of x, well, not x, this time it's 4 pi over 3, equals 2.09. But what is 4 pi divided by 3? 4 pi divided by 3 equals 4.18. Nine, I guess. And they are not equal. Okay, so you just need to give one counterexample. You could have used anything other than 4 pi over 3, just anything that's not between 0 and pi, obviously. So make sure you have that block definitely memorized for your test. Okay, next one, page 634, numbers 19 to 98. This is section 8.3 in the old edition, which is what we are using currently in class. That's the 5th edition. Okay, so this is going to be similar to other test questions. So I would definitely go through that section, make sure you understand the proofs. So what would be the best strategy to establish the identity? And of course, they could come up with a million identities. Okay, I already messed this up. All right, cosecant u minus cotan u equals sine u divided by 1 plus the cos u. All right, and then this would be a multiple choice type thing. So it would be like cross multiply, rewrite, cosecant u as being 1 over the cos of u, rewrite sine of u as being 1 minus cos squared u, rewrite cosine u as being 1 over the sine of u. And of course, they could be multiple choice answers on here, and you would just want to look at what would be your best solution here. Usually we typically look at just one side of the equation, so to cross multiply here would not make any kind of sense. So I would not cross multiply. If I look at the cosecant of u, and I'm looking at my index card there, the cosecant of u is equal to 1 over the sine of theta. So that does not make sense. You would not turn it into 1 over cos theta, cos u, or whatever. It's not even the right identity. Sine of u equals 1 minus the cos squared of u. Although I do believe that probably is an identity. I don't think you would want to mess with the sine and the cos. Usually if you have ones that aren't written in sine and cos, you want to convert them into sine and cos. So your correct answer is the last one here. Okay, and of course, there are multiple different ways. They're not going to make you complete an entire proof, but they might ask you a question as what would be the next step in a proof. Okay. All right, next one, page 644, numbers 31 to 36. This would be in section 8.4. Of course, this is also in the old edition, which is what we're currently using. This deals with all of these formulas. Okay, the cos alpha, cos beta ones. All right, so here's a problem that they might ask you. So sine of alpha is 4/5 between pi over 2 and pi. That's where alpha is in between. And then sine of beta is -2/5. And of course, if you would write that proper, that would be -2√5/5. And beta is between pi and 3π/2. And then the question would say, find sine of alpha plus beta. So you definitely need to memorize those formulas. For sure, on the test, make sure you have these memorized and those ones down there memorized. So your sine alpha plus sine beta, so that would be sine alpha cos beta plus cos alpha sine beta. So that's your formula. We're going to plug this stuff in. So sine of alpha, that's 4/5, cos of beta. All right, so to find that, you're going to need to draw your triangles for this thing. So this will be our alpha triangle. So sine, here's alpha, 4 and 5. So we're going to know that this is a 3, 4, 5 triangle. Oh, I already messed this up. Why did I mess this up? Look, this says it's between pi/2 and pi. And where am I at? I'm between 0 and pi/2. So I already messed this up. I'm in the wrong quadrant. So that's why it's really important to read. All right, let's restart this in the correct quadrant. That's why they give you the quadrants of where they're in between. So make sure you don't do what I did and make sure you actually read where your quadrants are at. Okay, here's the alpha again. So alpha is 4 and 5. So this has to be -3 because it's a 3, 4, 5 triangle. You could do Pythagorean Theorem. All right, now let's do the beta triangle since that's the one I really need for that one. All right, let's try to read this time. So beta is between pi and 3π/2. So there's pi, 3π/2, so beta's down here. I'll get the right place this time. All right, so sine, I'm going to go with this version here instead of using the simplified version. So here's my beta. So sine is -2 √5. All right, you're going to need to do Pythagorean Theorem. So the square root of 5 squared equals -2 squared plus your other b squared. So 5 equals 4 plus your b squared. All right, so we would subtract 4 on both sides. So 1 equals beta squared. So 1 equals our beta. So this, and of course, because we're in this quadrant and this is the negatives, it's really going to be -1 there. All right, so cos of beta would be -1 over square root 5. Plus cos of alpha would be -3/5. Sine of beta is -2 over the square root of 5. All right, and then we need to simplify all of this stuff. So I would rewrite this as negative square root 5 over 5. And I would rewrite this one over here as what they gave us originally, negative 2 square root 5 over 5. That's going to make it way easier to simplify. All right, 5 times 5 is 25 on the bottom. Negative 4 square root 5 on the top. 25 on the bottom. 3 times your 2 would be 6 square root 5. 6 minus 4 would be 2 square root 5 over 25. And that would be the one that you would be picking as your answer choice. All right, and the last type of problem that could be on there is they're going to give you a graph. So we'll do the normal sine graph here. Okay. So pi over 2, pi, 3 pi over 2, 2 pi. Of course, this would be 1 and negative 1. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, so I just have the normal sine graph. So it will say, what is sine inverse of 1? And I'll just have like a question mark or something like that. Okay, so all you have to do, and this is, you're reading it right off of the graph. So you come over to the 1, and then you would read down, and you read the x coordinate. So my answer would be pi over 2. Okay. All right, so this should help you a lot with the third test. Good luck on your test, and please make sure you also watch the next video for test 4. Have a good day.